You made it. Good. Good. I'm glad you were able to come. It's good to see you guys. As always. Guess what we're doing? You probably see it right here. Common logarithms. Now, what does that mean? Well, today we're going to be taking all these ideas of logarithms and putting them together and solving some equations, solving some things that we want to find out, but mostly solving equations, because a lot of their basic algebraic skills involve how do you solve an equation. There's different ways, and you've learned many ways. Now we're going to solve equations where we don't know the exponent. A very simple example is this. But you know the answer to this. 10 to what power is 1,000? Well, it's 3. So what it means is a log of base 10 of 1,000 is 3. And that's what a common logarithm is. It's something with a base of 10. We know that's 3. So when we use log, the symbol, we're assuming it's base 10. That's the common logarithm, a base 10. It's going to help us figure out problems like this. Now, we don't know what the answer is exactly, but I know that 10 squared is 100. I know that 10 cubed is 1,000, so the answer has to be somewhere between 2 and 3. Well, guess what? We're going to figure out equations like that today. First thing I want to tell you is you're going to need a calculator for this. Now, on your 84, the log button is right there. It just says LOG. That's what you're looking for. You're looking for the buttons that say LOG. Log. We assume it's base 10. Notice the iPhone over here. It says log base 10. They don't always say that, but they are assumed to be base 10 unless we specify otherwise. So this is a Casio. There's your log button. This is the calculator on my PC. There's the log button. That's what you have to be able to do today. Now sometimes you type in the number then hit log, like on the calculator I'm going to use today, or sometimes you hit log and type in the number and hit enter, like in your 84s. So a quick practice. How do we do log of 101? Well, we take our calculator. I'm going to type in 101 and hit the log button. And there it is, my log of 101, 2.0043. And it kind of doesn't make sense because we know that 10 to the second is 100, so this is going to be a little bit more than 2. 2.2 log, 0.3424. All right, log of 0.05. Now, 0.05 is less than 1, so that log is actually going to be a negative. So negative 1.3010. So as long as you know how to punch that number into the calculator, you're going to be all right. Because now we're going to use logarithmic properties to figure out certain things. Here's an example. pH. pH measures the level of acidity in a product. It's either acidic or what we call basic or alkaline. Now, if you're in chemistry, you know these things. If you're not in chemistry, you might not know these things, and that's okay. I'm not really here to teach you about the chemistry aspect of it, but how do we use a formula to calculate pH levels? Well, the formula is given right here. How do I use that to figure out the pH level or the acidity of milk? All right. And just so you know, on the scale, the lower the value, the more acidic it is. Sulfuric acid is close to a 0. Okay. Water should be right neutral, right in the middle, 7. The scale goes from 0 to 14. 7's right in the middle. So how does milk fall into that scale? Well, let's take a look. I know that my formula is negative the log of the concentration of hydrogen ions. You can look that up if you want to know what that's all about. But that measures the acidity or alkaline or base level of a product. So I'm just doing the math though. I'm just putting this in here and seeing what it gives me. Now you know how to do logs when you have things you're multiplying. It means you add these two. So it's the log of 2.51 plus the log of 10 to negative 7. I didn't put a base. Now if I don't put a base, remember that assumes the base is 10. Oops. All right. What is the log of 2.51? Well, I don't know. I had to calculate that. And the log of 2.51 is 0.3997. Now here's the fun part. I technically don't have to calculate this in the calculator. I mean, I can. I could put log of 10 to the negative 7. Remember, the log is a base 10. So it's just negative 7. Log, base 10 of 10 are inverses. They kind of cancel each other out. It's just negative 7. So if I add these two together, I get, where did I go again? Okay. Negative 6.6, because we're just rounding it to the nearest tenth. And it's 6.6. So milk is almost right in the middle there. So I'm going to show you a little chart here. Neutral is 7. Your blood's a little bit above neutral. Milk, it says it's between 6.3 and 6.6. Slightly acidic, and we calculated it to be 6.6. All right, coffee. Is it acidic or not? Okay. Things that are acidy tend to taste a little bit sour. Lemons are very acidic. Soda is very acidic. Hydrochloric acid, very acidic. But you don't drink that. And you go the other direction on the alkaline scale or the basic scale, you're talking about bleaches and cleaners. Okay. So each end is very strong, but they're strong in different ways. So let's do the old formula here. So it's 1 times 10 to the negative 5. So it's the log of 1 plus the log of 10 to the negative 5. Okay. Now the log of 1 is actually 0, because anything to the 0 power equals 1. And the log base 10 of 10 to the negative 5 is negative 5. So you add that together. So coffee is a little bit acidic. Not too bad. So this scale down here was fun. I looked it up. Liquids like drain cleaners and things like that and bleaches are very, very basic or alkaline and are very strong. Neutral is things like your blood, water, milk, things like that in the middle. And then down here, hydrochloric acid, battery acid, very acidic. Think about how close lemon and vinegar is to that. And I eat lemon all the time. But it's very acidic. Okay? But again, this is not about the chemistry. It's about the mathematics and using logarithms. And that's one way we can use logarithms. So now we're going to do a few examples of solving equations. So 2 to what power is less than 25? Well, what I got to do is figure out is how can I get this exponent out? I know that 2 to the 4th is 16, and I know that 2 to the 5th is 32. We've been doing those for a while. The answer's got to be between 4 and 5, but how do I figure it out exactly? Well, here's the trick. I can take the log of both sides. It's an algebraic operation, taking the log of both sides. Now, what does that do for me? Well, that now means that exponent can drop in front, because that's one of the properties of exponents. And now, even though there's logs, these are just numbers. It's just simply solving an equation. Divide both sides by a log of 2. And I have to put it in my calculator. And when I put it in my calculator, what do I get? 4.6439. It kind of makes sense, doesn't it? I knew it had to be between 4 and 5. If I put in 4, 2 to the 4th is definitely less than 25. 2 to the 5th is greater than 25. So this is my answer. This is how I'm going to be using logarithms to figure out equations. I need them to figure out equations when the variable is an exponent, because the properties of logs turn exponents into multiplication problems. And to solve, I just need to divide. Right, so the log of 120 divided by the log of 5 is 2.9746. And hopefully it makes sense. It's almost 3, right? It's very close to 3. What's 5 to the 3rd? 5 times 5 times 5 is 125, so it's pretty good. This is our routine, our procedure for solving logarithmic or equations with exponents of unknown exponents. Take the log of both sides, then I can drop the z in front, and now it's just a matter of calculator. Divide both sides by the log of 6, and z is going to equal approximately 2.1319. That's logs, ladies and gentlemen. And it doesn't matter if it's an inequality or an equation. It all works the same. Okay. Drop the m in front. And some of you guys might know, what is the log of 100? That's 2. Do you have to know? No, because you can put it in a calculator if you want. Now just be careful. You're not dividing 100 by 9. You're dividing log of 100 by log of 9. So if you do that, what you're going to get is 2.0959. And again, check a number, see if it makes sense. So m has to be bigger than 2. So give me a number bigger than 2.0959. How about 3, right? If 3 is correct, 9 to the 3rd is definitely bigger than 100. 9 times 9 times 9, you're talking about 81 times 9. Definitely bigger than 100. Hence, our answer is this. All right. Get the idea? Now, of course, these are fairly straightforward. There's nothing too crazy going on here, but the crazy part is making sure you know the log properties. We spent a while getting to this point. So hopefully when you see that this is pretty straightforward, you're like, oh my gosh, all that work I did for this, hopefully it paid off. So in the calculator, you put log of 47.9 divided by the log of 3.5, and you will get 3.0885. All right. So I'm going to end this video here. And if you have any questions, let me know. Or if you're up for it, just go ahead and jump. The second video is going to start with question number 11. So I'll see you in a minute or two or later.